So we did everything arithmetic. Now we're going to do everything geometric. A geometric pattern is technically a multiply-divide pattern, but we don't, instead of saying dividing by 2, we're actually going to say multiplying by 1/2. It's nicer to say that. So you're just going to be a multiplying pattern. Now that actually should remind you of an exponential pattern because it's y equals a b to the x. They have similarities. The difference is here, it's kind of like you're taking the 0 term and the pattern to the x. Where in a geometric pattern, you're taking the first term and then the pattern to the n-1. So just like it was with arithmetic, they asked for the first term in the pattern, and then slope-intercept was 0 term and the pattern. Same thing, exponential, 0 term and pattern. For a sequence, first term. And some of you go, why are they doing that? Well, this, when you were dealing with exponential and you were graphing, you always started from the 0. But in a pattern that's geometric for sequences, you don't start with a 0 number. You start with the first number. They're like, okay, what's the first number? So it's a little bit different. Okay. All right, so let's do this. We notice the pattern is times 2 times 2. That's a pretty 2. You're welcome. So that is my R. That is my ratio. Okay, a ratio is like a fraction. And so in a sense, when you multiply by 2, you're technically multiplying by 2 over 1. Or when you multiply by 1/2, that's already a fraction. Okay. So then I'm going to write down the formula so that I can memorize it. They need the first term. And some of you are going to realize how much easier it is to get the pattern here. And there's the pattern. So my formula is 5 times 2 to the n-1. Now I'm going to find the 10th term in the sequence. So I'm going to take the 10. I'm going to plug it in. 5 times 2 to the 9th equals a sub n. So I'll use my calculator. 2560. That is the 10th term in the sequence. Now some of you said, no, I want you to write it as exponential. Okay, if you're writing it as exponential, you're going y equals the pattern, which is 2. Oh, look at that. Okay. And then, wait, oops, that should be n-1. Just kidding. So, oops, I messed up. No, I think we're good. So then this would be 2 to the x. Well, if this is times 2 times 2, to go backwards, I have to divide by 2. Well, what is 5 divided by 2? 5/2. So that is exponential, and this is geometric. Okay? I use the first term. Here I use the 0 term. Next thing, if I wanted to create a recursive sequence, remember, this is explicit. This is my explicit sequence. Then I would go a sub n equals, what am I doing to the pattern? I'm multiplying by 2. And then I have to give the first term. I don't have to give the first. I could technically give the second. But I need to give a term so I can get the next term. What am I doing to the previous number? Multiplying it by 2. Multiplying it by 2. Okay. Next one, what am I doing here? And some of you go, I don't know. Dividing is so much more difficult to me. So I can use my little calculator. And it tells me 10. Okay? So that means I'm dividing by 10. But I don't write divide by 10. I write times 1/10. That is my R. That is my ratio. Write down the pattern. Take the first term, plug it in. Take the ratio, plug it in. That is my explicit rule. Now that I have my explicit rule, I can plug 8 in here. So I'm going to go 5,500, 1/10, and then 8 minus 1 is 7th. So 0.1. 0.1 is equivalent to 1/10. To the 7th. It's a very simplistic calculator. And I get 0.0555, but maybe I'll see what it looks like as a fraction. Oh, it's not letting me do it. So then my 8th term in the sequence is 0.00055. If I wanted to do this as exponential, I would go y equals, I want the 0 term. If this way is divide by 10, this way is times 10, 55, 1, 2, 3, and it's still the pattern. That is my exponential equation. If I wanted to make it recursive, I say, okay, what am I doing to the previous guy? Multiplying by 1/10. Make sure you give me a term so I know where to start. Recursive. Okay, next one. This is positive, this is negative. This is positive, this is negative. Oh, okay, so that means I have to multiply by a negative to change the signs. It's being divided by 2, but we don't do that, so it's multiplied by 1/2, negative. A sub n equals a sub 1. Geometric. If I wanted the exponential, instead of dividing by 2, I'd multiply by 2 to get the 0 term. I might have multiplied wrong. And then negative 1/2 n. The n, just as a side note, but that's not part of the question, they want the 11th term, 9,600, negative 1/2, 11 minus 1. If you don't know how to use your calculator for this, then you're going to get the wrong answer, so make sure you can do this. Negative 0.5. I'd rather do negative, parentheses. I'd rather do a decimal. It's easier for me. And then to the 10th. 9.375. So the 11th term is 9.375. How am I messing with you on this one? Because these are all R. These are geometric. I messed with you because this is -8, which means that's my difference, which means it's not geometric. This one is, is arithmetic. Okay. So that means you're going to go a sub n equals a1, n minus 1 times d. The first term plus n minus 1 times -8. Distribute. Simplify. That is my formula. Now take 14, plug it in. Negative 8 times 14 plus 29. 112 plus 29 is 83. A sub n equals negative 8. A sub 14 equals negative 83. Okay, so I want you to fill in what's missing. Well, how did we do it before? Let's look. When it was arithmetic, what did we do? We took the first term. We used the last term to find the pattern. Remember, if we had the pattern, if it was times 2 times 2 times 2, it would be a lot easier. So I'm going to do the same thing. That's my a sub 1, 2, 3, 4, a sub 5. I'm going to write down the formula so that I memorize it. Put the 1 in there. I don't know my pattern. If I knew my pattern, my life would be easier. This is my 5 minus 1 equals 81. So I took my 5. That went in there. I took my 81. It went in there. I divide by 1. 5 minus 1 is 4. I take the 4th root of 81. So I'm taking everything to the 1/4 power. So 3 to the 4th to the 1/4 is 3. Now some of you go, cool, you got the pattern. Well, what are you doing when you do an even root? It could be plus or minus 3. Because that means that if this was positive, it would be 3 times 3 times 3. But if it was times -3 times -3 times -3, they both work. So you could have a positive ratio or a negative ratio. Okay, that only works when you even root. It doesn't work when you odd root. Okay, let's do the next one. This is the first term, second, third, fourth, fifth, sixth term. So I'm going to go a sub n equals a1 r to the n minus 1. I take this, plug it in. I take this, plug it in. So I'm going to go point. I'm actually going to write it as 1/10. I just can't help myself. I don't like decimals as much. 1, 1, 2, 3 to the r to the 6 minus 1. 1/10 divided by that is actually 1 over 1, 2, 3, 4, 5. If you don't know that, you are using your calculator and getting that. Well, I know this is really 10 to the negative 5th equals r to the 5th. Take it to the 1/5 power. If I take 1/5 to the 5th, that's gone. And 10 to the negative 1 is 1/10. That is my ratio. It's to an odd power. So since it's to an odd power, I'm not going to have a plus or minus. And some of you go, why are you doing all that? Just use your calculator. I don't want to use my calculator. I don't need it. I can do this without it. Okay? Make sure you know this kind of stuff, because this is the kind of stuff, those little details that can get intimidating when you're doing a problem like this. So if I'm doing it times 1/10, I'm really dividing by 10. So I'm taking away 1, 2, 3. There's only 3 zeros. Take away 2 zeros. Take away 1 0. Take away no zeros. Take away. That's what 1/10 represents. And there's my answer. Okay? All right, let's do this one. Oh, we got a fraction. We'll be okay. 2, 3, 4. A sub n equals a1 to the r to the n minus 1. And some of you go, Ms. Rifkin, how do you know these are geometric? If I don't tell you what it is, you don't know what it is. So I'm telling you these are geometric, but I have to let you know. Here, I don't have to let you know because there's a pattern. Based on the pattern, you decide arithmetic or geometric. Here, I didn't give you the pattern, so I have to tell you if it's arithmetic or geometric. Okay? So negative 27 over 4 equals 2r to the 4 minus 1. I'm going to divide by 2. If I'm dividing by 2, I'm really multiplying by 1/2, which is negative 27/8 equals r cubed. What do? Take it to the 1/3. So that's negative 3 cubed over 2 cubed, which means r equals negative 3/2. 2 times negative 3/2, negative 3. 2 on top, 2 on bottom, bye-bye. Negative 3 times negative 3/2 is positive 9/2. And if I multiply that, look at this, times 3 times 2, I'm good to go. I'll finish these last problems in the next video.